All right, everyone. Welcome to the Utility Broadband Alliance webinar series and to today's really insightful and technical and business-driven topic. We are really honored today to have 4 of our members coming together to share their insights really around security and reliability of the grid, particularly with private LTE networks. And I want to remind everyone that our webinars are interactive. So while the system does have you all muted, please use your toolbar under the questions to type in any questions that you have for the panelists. We will hold some time at the end and we'll answer as many of those as we can get to. Obviously, if we don't get to them all, then our panelists will follow up with you after the event individually, because we don't want your questions to go unanswered. It's my pleasure to introduce the topic today, to introduce the panel today, but I want to remind you before we do, and we'll talk again at the end, that you can meet with all of these wonderful UBBA members at the UBBA Summit and Plugfest in November. And if you haven't registered yet, registration is open and we're in the early bird just through the end of the month, so you'll save some money there. And get your hotel room booked, so you'll save some money there as well. So check out ubbaplugfest.org for all those details. And now sufficiently, I believe we've gotten everybody logged in from the GoToWebinar tool. And I'm going to turn it straight over to Jean Jones from Anterix. Jean's going to take us through and lead the panel today. And again, I'll be back to read your questions at the end. So Jean, it's you, sweet.
All right, thanks so much for that fantastic intro, Bobby. Let's get right into it. So super excited to have this panel of experts here today for you who are, great deep industry experts in the area of security, utilities, and private LTE networks. So I'd like to just quickly introduce the panelists that we have here today. Jeremy Haynes from our own Anterix. He's our cybersecurity architect. So welcome, Jeremy. We've got Efrat Harari, who is the Director of Product Management from OneLayer. Welcome. We've also got Ken Kaminsky, who is the Director of Cybersecurity for Regional Carriers, Utilities, and U.S. Federal from Ericsson. Welcome, Ken. And Enrico Milanese, who is the Head of Security with Telit Centurion. So quite a fantastic lineup for you. Before we kick it off, did want to mention that this presentation here today is really based on a security white paper that we developed together called Security Considerations for Private LTE Grid Communications Networks. You can find that on the Anterix website under the resources page, or reach out to any one of us, or check out the other websites as well to download that paper and get a copy. So if you'd like to learn more after this webinar session today, so I encourage you to do that. So let's get right into it with our first speaker, Jeremy from Anterix. And Jeremy, if you can just start off with detailing some of the requirements in your experience of utility secure smart grids, and specifically also, what are the security capabilities of private LTE? We know foundationally it offers a lot, but there's also a lot of enhancements as well. So if you can take us through those topics to kick it off, that'd be great.
Yeah, absolutely. Good afternoon, everyone. Diving right in, yes, smart grids. The benefits of smart grids. We know those quite well. However, something that we don't necessarily think about too often is how does this increase our risk footprint, right? For the requirements of what a smart grid needs to function properly. So as far as smart grids, you need to have coverage for wide areas. There's going to be a number of devices across vast areas that need connectivity for smart grids to work properly. You need to have complete visibility into each of these devices, management, and complete data flows so that large sets of data can continuously flow regularly in order to help provide the data needed for decision making and for proper energy consumption. Each of these IoT devices are part of a critical infrastructure, and they have unique security requirements because of that. So an attacker could see any of these IoT devices as perhaps an attack avenue and a means to gain access to a much larger network. So ensuring that you have proper device requirements and layers of security even within the IoT devices is very critical. Having all of the data points, all of the communications flows reliable, so that proper analytics and energy flow can operate the way it is intended to for smart grid. You have to have unique policies for the communications flows for these devices. There's going to be a large number of devices communicating across private LTE network. You need to ensure that you are able to regulate who's able to communicate with whom, and ensure that you're not overwhelming any part of your network. So this is absolutely critical, especially with smart grids. Physical security for each of these devices that are spread across vast areas is very, very important. Cybersecurity is extremely important, but physical security also plays a major part in securing smart grids. These devices are from everywhere to people's households, to streets, to buildings, and to ensure that they're not tampered with, or that if they are, that can be properly detected, is absolutely critical to ensuring the security of the broader utility network. There are certifications in place to ensure that certain security requirements are met for these devices, and it's absolutely important that those accreditations and those certifications are in place and are recognized and are a strict requirement for these microgrids to ensure that it is not an attack avenue. Any of these devices are not an attack avenue for the broader utility network. Next slide, Gene. So in order to properly secure private LTE networks, there's a common saying that all roads lead to NIST, and in my opinion, it truly does. The NIST pillars have been standing strong for quite a while. We typically start with proper visibility into the network, knowing what devices are connected over your LTE network, knowing which devices should not be connected on your private LTE network are absolutely important, because not only can they create congestion within your network, but they can also impede important communications that are needed for the microgrid to function properly. Identifying and knowing what's on your network can also help you identify if there's something that should not be there that could potentially be malicious, or could be a threat actor trying to gain access to your network. So identifying all the assets on your network and having visibility into that is absolutely critical. And then of course, protecting that network. These distributed IoT devices are a little bit different than the old design, where you have castle walls and everything is behind these castle walls, and you have strict layers of defense on the outside. These IoT devices are standalone, internet connected. You really have to ensure that these devices themselves are hardened. You don't want threat actors to see any of these and think, well, that's a soft target, I'm going to go for that, because threat actors typically like easy targets, right? So the better we can protect these devices with different layers, the better. The ability to detect any sort of anomalies within your network, not even just a threat actor, conducting normal threat actor stuff, but something that is anomalous, that is outside of a baseline, not necessarily a payload being dropped on your network, but are there threat actors that are trying to disguise their activities as something non-malicious? So the ability to have anomaly detection and to be able to detect anything that is outside of the baseline is absolutely critical. There are a number of capabilities that can help facilitate that. And you can satisfy that on a private LTE network with the ability to deploy a number of capabilities where you may not be able to do elsewhere. The ability to respond on a private LTE network, having full capability to enact security controls to block certain communication flows, to isolate devices, that's absolutely critical if there is a detection. And the ability to add protections where you may see gaps in the future, or if there's any detections where you need to respond and perhaps patch, or not just isolate devices, but perhaps replace those devices. The ability to respond is absolutely important, and having that ability on a private LTE network it is going to allow you to keep the smart grid functioning the way that it should. You may not have that ability on other types of communications, but it is certainly a capability within private LTE networks, given that you have full ability to design the network and apply the security capabilities that you see fit. And of course, last recover, if there's any sort of malicious event, or if there's any sort of outage in which you need to recover, or you need to replace a device, or you need to patch a device, or if you need to isolate devices and rebuild your network, having that ability to do that quickly and effectively is not just going to ensure that customers have uptime with their utility service, but also the utilities will be protected as well. The ability to rebuild certain aspects of the network very quickly, that is functionality that is going to be absolutely critical. So these 5 pillars, being able to support these with security capabilities that you can apply to your private LTE network will absolutely ensure that you are providing the best protections, not just for your customers, but for your broader utility network as a whole. All right, Jean, I'll hand it off.
All right, fantastic. Thanks so much, Jeremy, for taking us through all the capabilities of private LTE, giving us an overview and of all the security layers that can be leveraged. Now on to you, Efrat. From one layer, we know you all have a lot of experience working with utilities and insights into security. So give us one layer's perspective on your expertise in working with utilities and securing private LTE networks.
Sure. First of all, thank you for the introduction, Jane. I really appreciate Jeremy's points, and I see strong connection to what I'll be covering today. So let's dive deeper into the topic of securing private cellular network, specifically from the perspective of end devices. So when we're thinking about securing private cellular network, we must start from the frameworks of the classic security best practices that we know. When we try to take them and apply them on the private cellular networks, we understand that probably we cannot just copy and paste them. The reason is that private cellular networks have some unique challenges that affect every security level. And this is exactly the gap that I want to cover today, and think together how on one hand we can provide security standard that we want, and then on the other hand take care of all of these unique aspects of cellular network. In order to cover that, I separated the discussion into 3 big blocks or building blocks for us. The first one is visibility, the next one is posture, and last will be the continuous monitoring. So let's start from the golden rule of security: you cannot protect what you cannot see. So when it comes to the cellular networks, it's a bit more complex, because when we are talking about cellular devices, they are built of multiple components. We have the SIM card, we have the physical device, and we have the modem. Each one of them is a different entity that has its own risks. And when we are talking about visibility, we must take care of each one of them. And actually, I mean, can IMSI, for example, as an identifier can be good enough for me if a SIM card can be swapped? Or IMEI can be good for me if IMEI can be spoofed, for example? As far as we understand, no. We must take the whole picture together and actually create a profile and really understand what is the device connected to my network. Is it a phone? Is it a camera? And if it's a phone, is it a Samsung or an iPhone? It really matters. It matters for the visibility and then for the upper layers of security. Except for the cellular devices, there is another challenge that we see. We know today that because of the lack of devices that support the private cellular bands, many utilities choose rightfully to connect non-cellular devices to the network using adapters. Adapters can be cellular routers, dongles, hotspots, Bluetooth, any of these types of adapters. They basically open the door to many other devices to be connected to the network, devices that bring other security risks with them. So when we are speaking about visibility and coverage in visibility, we must take care not only on the cellular devices connected to the network, but also to the non-cellular devices connected to the network via adapters. So now when we have building block number 1, we can continue to number 2, which is posture. When I say posture, I actually kind of opened the definition to be a bit larger than we understand it today from other fields. And I include here any rule that is setting the expectations from the network. It can be, for example, access control, what is allowed to be even part of the network. It can be segmentation, what is allowed in terms of communication in the network, and anything related to it. So it's above visibility for a reason. It has to be built on the context of visibility. For example, when I'm speaking about segmentation, I can create context-based segmentation only building on the context from the visibility part. If I want to set a policy saying, hey, I don't want my phone to be communicating with any of the tablets, I must know first what is a phone and what is a tablet. And then another example can be, I want my cameras only to be communicating with the camera server. For that as well, I must build on the visibility that I gained before. For access, it's just the same story. On one hand, I can base on identifiers, it's true. I can set a list of IMEIs and say, hey, only these devices can be connected to my network. But not all customers, especially when we're talking about large scale utilities, not necessarily we know how to set all those IMEIs. But what we can do, we can decide that on access control, we again base on the context of devices. And we can decide, for example, to say, I don't want a specific vendor to be part of the network, or I allow only specific vendors to be part of my network. And then set context access control that is based on the type of devices that should be connected. We can even speak a little bit when we talk about posture, also about the opportunity to discuss some supply chain security. Because if we discuss in the visibility part that we take care about the differences between the different components that make a device in cellular network, the SIM card, the physical device, and the modem, we can set policies in the posture part that refer to each one of them, as each one of them, even separately, bring their own risks to the network. So we don't even have to address it per device as a whole, but per the different components of a device. Now I'll continue to the third building block, which is the continuous monitoring. Continuous monitoring is actually coming again for a reason above the two other ones, above visibility and posture. The main role of the continuous monitoring is, on one hand, again, to make sure that the posture is kept, but then also catch those cases that are related to unexpected behavior. So even if I didn't cover the behaviors that are not allowed in my network as part of the posture, I still expect the continuous monitoring to catch those cases. And of course, I'll use some examples. So let's imagine some technician is coming to my facility and doesn't have a reception. they see, or he sees, some cellular router right next to them, and disconnect whatever it is that is connected to the cellular router and connect their computer instead. Once they did that, there is now a new device connected to my network, a non-cellular device connected to my network, adding a risk to the whole network. These kind of activities are an anomalous activity, something that I want to detect. Another thing that we can speak about is, for example, I see device moving around town. If it's a tablet or a phone, then it makes sense. But if it's a meter, for example, an electricity meter, then it should raise a flag for me. So we expect both things from continuous monitoring to make sure that the posture that I decided on is kept, the access control is kept, the segmentation is kept, but then also detect any unexpected behavior and raise a flag for me in these cases. So only when we combine all three, visibility, posture, and continuous monitoring, we can expect high-level security standards that also take care of all the aspects, the unique aspects of private cellular networks. Thank you.
Thanks so much, Efrat. Yeah, that was very insightful to take a deep dive into the particular areas to watch out for security in cellular networks in particular. So thank you for that. Let's head on to Ken now. Ken from Ericsson, if you can take us through the 3GPP and application layer security capabilities, and also the security architecture in particular for private LTE, please.
Yep, absolutely. Thanks, Gene. So on the this diagram here is showing you some of the major components that come into play when you're looking at it from a 3GPP and an application layer perspective. The app layer there is the device itself. So the application may have security controls embedded within it, like for encryption or authentication and the like. The stuff that the network provides is down below. And over on the left there, you have the device, which is connected into the network via secure device authentication and authorization, based on a key that's located within the SIM card that's embedded within the device and protected. Over the air, you have two different things that are going on. You have integrity first, and then second, you have encryption going on. So the integrity is the first piece that's applied, and that's just looking at every bit that went over the air. It's ensuring that it was actually received properly in the right order on the other end. That's integrity, and it's usually done by some type of a hashing function. And that's the first thing that's done to the data. And then the second thing is encryption, where an encryption key and an algorithm using standards-based AES encryption is used to actually encrypt that traffic. And you have different streams that are encrypted and integrity protected. You have a stream, for instance, from the signaling side that goes all the way from the device all the way into the core of the network. So that's going over the transport, the IP transport in between. That's its own encrypted and integrity protected connection. And then you have the signaling and then the data or the user plane that have those also applied to it. When you're looking at the IP network, that's in the center there, and that's usually the utility network is usually running an MPLS type network there. The protection there is using standard IPsec protocols that will protect the signaling and the user data going over that particular portion. And that will connect into a firewall from the regular firewall vendors. They're just running a load that's specific to the cellular network. And in 3GPP terminology, we call that a security gateway. And that's really there primarily to protect the traffic in terms of integrity and encryption, but it can also provide firewall functionality at the same time. Next slide, Gene. This is showing you a kind of a bigger picture of the security architecture here. And one of the things that I want to call out is you see all of these logs and telemetry, all this information coming off the radio nodes and the core applications. All of that is flowing in general in a regular enterprise network. That would flow to what's called a security information event management system, which is found in the upper right. And that's, you have vendors such as Cisco Splunk, IBM QRadar, Sentinel-1 are big players. There's a number of them also that are out there. A lot of the significant security spend in an enterprise network goes into that particular piece of technology. And that looks at all of the information and it tells you, it processes that and it tells you what's actually going on your network. And your incident response teams can then use that to respond to security incidents. One thing I want to point out here is that in a private LTE network, this is telco technology, and the SEM vendors that are out there in the marketplace are primarily geared towards the enterprise and the OT space. And they don't necessarily have all the rule sets, they don't actually, to handle the telco vendors' log streams and telemetry streams. So someone's got to do that. And in order to fill that and other use cases, the telco vendors have products in this space. I call it a telco security manager. Ericsson has a product called Ericsson Security Manager. Nokia has a like product, in this space also. But the telco vendors had to bring these to market in order to fill that gap between the telco world use cases that were not being met by these enterprise-focused tools. So you'll see things like that is one thing that it will handle. It'll process all of the data coming from the maintenance plane, all those logs and telemetry, and it has all the vendor rule sets. It understands all the vendor log formats, the vendor telemetry formats, and it can process all that data and then report up to that SEM and let it know the issues that it found. So at a high level, this particular product sits underneath the SEM and it handles the use cases that are telco specific. Some of those other use cases are things like endpoint detection and response agents. These are really critical in a modern cyber infrastructure in order to find, in particular, the really advanced attackers. And these are implemented as agents within those network functions that are running within the core network. They can also run as subcomponents to the radio networks themselves. So in particular, Ericsson has an agent that can run there on the radio node that's unique to that particular radio node. These EDR agents are critical, like I said, and they generally will report up to this specific piece of technology and this product type, and it will tell it everything that it sees, and then it will tell the SEM in its turn when it sees a problem. Other things this will do is like finding false base stations that might be running within the spectrum of the utility grid. So if someone's trying to spin up a false base station to get different endpoints to try and connect to that, this particular product type will tell you that. It gives you a nice map and shows you where that type of activity is going on. It'll tell you things like jamming, if you've got jammers that are running out there in your space. And they also run different applications to reduce the attack surface. In terms of helping the utility to manage all of the security configuration of all the different devices that are out there. So there are applications that we're running here that will allow you to run security templates on all your devices, and it will put all those configurations on all those radio nodes, those transport devices, the core network applications, the management applications themselves, It'll define rules for that, and then it will periodically go out and check those rules. So if anyone actually changed one, maybe, this happens sometimes for good reasons, maybe during some emergency situation, someone does an emergency change, but then they forget to flip it back. That periodic looking across the entire infrastructure is a good thing here because you don't need human involvement. The system will just go ahead and build those security configuration controls right back in on the node that was affected there. So that's an important thing when you're looking at, the overall architecture, is to remember this, because you need a product like this from one of the vendors in order to meet those use cases that are not being met by the current tools that are there. And then the last thing, that I recommend is having a next-gen firewall at the exit point from that core network, in between that and the data center. And this is to basically segment the entire cellular network on its own segment, in essence, so that from a security standpoint, you could build some rules there that it's given you some excellent internal segmentation. And those rules will only allow all of those cellular endpoints to connect to the proper applications that they're connecting to within the utility data centers. It's an extra layer of security that's there, and it's something that we highly recommend customers to go ahead and pop in there. And that's what I've got, Gene.
Excellent. Thanks so much. Great insights on the architecture, Ken. Thanks for that. And now on to you, Enrico, from Telit. Give us Telit's perspective. We know you have a lot of insights on this topic as well. Give us the perspective from the cellular module viewpoint, please.
Yeah, sure. Thank you, Jean. Yeah, in this last session, maybe I will try to provide some more details at the edge side on the final embedded application, which is exposed physically on the field, as mentioned before by the other expert, and especially with a specific detail on the connectivity modules, where Telit Synterion is the Western leader in such market. But before deep dive in this topic, maybe just to highlight also the audience with some basic statistic that generally speaking, the cyber attacks are growing worldwide, and critical infrastructure attacks on critical infrastructure are growing also fast. Since 2018, if I remember correctly, the International Energy Agency warned about this rapid growth of cyber attacks. And also the North America Electric Reliability Corporation estimates that in the last years, there is an increased exposure that they call in weak spots of potential vulnerabilities in software and hardware components that it could increase the attack scenarios, and this growth is in double-digit in percentage in this last year. So in this ecosystem, as described also by the other experts, in complex infrastructures like this, a single weak point can compromise the security of the entire or part of the entire infrastructure as well. Just to spend a few words more in detail regarding what is in detail a connectivity module, because there is a little bit of misconception sometimes. Connectivity module is a communication component that needs to be integrated in the final device and forms the cellular communication link. It handles all the traffic in and out within the final application. One common misconception is that this chipset we need to take into account that are complex subsystem running its own operating system with million line of code, with several interfaces and functionality. For sure, connectivity baseband chipset provided by the well-known semiconductor manufacturers are based on the 3GPP specification. But on top of this, several manufacturers, including Telit, provide value-added features and services to enhance the product capabilities and to better support the final customer use cases, also from a cybersecurity perspective. So these subsystems with such enhanced and detailed features can have, for instance, we can have embedded processing capabilities, offload of secure application communication protocol, device management capabilities, digital identity, just to mention a few. So these just to give you also the nuance that module manufacturers has a big responsibility in the final security posture of the device. And for this reason, one point that I would like to emphasize, as mentioned also before from the other panelists, was the supply chain security and risk management. Also in this at this level is a critical element in order to manage the risk of the final application, and especially in the smart grid and critical infrastructures ecosystem. So the usage of a trust partner is a key pillar, I think, to ensure resiliency and security in solution that should stay in the field for several years. How a connectivity module can support LTE private network transition, probably one element could be the evaluation and adoption of embedded SIM support, which can provide several benefits to enhance the cybersecurity posture of the final solution, and can promote an easier transition to LTE networks. It can be helpful to do a gradual transition based on the business case and the specific use cases, of course, from public to private infrastructure, or even help sometimes to extend the coverage of the private LTE deployment by complementing them with public LTE networks, so to have more profiles on a single SIM. And this is, I think, one aspect to take into account in the final solution to be evaluated. As I stated before, connectivity modules play a key role at the edge side and can provide also several cybersecurity capabilities can be used or relied on the final application to enforce the final product security posture, like topics like data communication encryption, both at the cellular radio layer and at application layer based on the industry standard, and can be configurable within the specific customer use cases. Secure data storage to store in encrypted form and securely data, customer data or configuration data. Trusted firmware execution to prevent on the field potential misuses against unauthorized code execution or against malware. Secure access control mechanisms to prevent potential abuses. And one element that most of our customers are relying and are using, especially in the utility sectors, functionality that could help to detect potential attack scenarios or misbehavior to increase also the device resilience. So topics like detect denial of service attacks, or even detect in the field jamming attacks at radio communication level, just to mention a few. So as you can see, these components, as I said, play a critical role in the final solution. So the adoption of trusted suppliers in the chain is within certified processes and product is pivotal for the benefit of the whole solution. So just very briefly, this was my outline with a slightly different perspective from the other experts, just to give you also these elements in this from this point of view. And I see that the connectivity modules could also act as enablers for private LTE adoption and in the transition in the private LTE solution and integration. That's my part, Jean.
All right, thanks so much, Enrico. I appreciate it, your insights. And now we're moving on to the Q&A portion. Bobby, could you let us know what we have in the Q&A chat?
Yeah, thank you so much. I was busily taking notes there, but I want to encourage everyone to remember to use your question toolbar and type in your questions for any of the presenters here today. We have one, you guys really went deep on the technology, and that was great. Appreciate that. Talk a little bit about what are the most critical security capabilities for utilities, and how does private LTE address them? And that can go to anybody.
I'll take a shot at that.
Oh, go ahead, Ken.
Okay, you can go first, Jeremy.
Well, I'll tell you what, I'll lay it out for you and you can run with it. So, you know, private LTE really, more than anything else, is an enabler for leveraging some of the best practices and best capabilities there are that you can use on a LTE network. So, it's in my opinion, it's really hard to say there's one particular aspect that is more important than the others. I mean, they really all play a complementary role to create a very layered approach that is absolutely necessary to protect against an evolving threat landscape. The ability really to be able to evolve and stay in lockstep with threats and to have that flexibility on your own network, I think is absolutely critical. And I think not being a part of a larger target like a larger telecom network is going to be absolutely critical as well. So being able to kind of fly under the radar a little bit with the private LTE, security through obscurity, I guess you could say, a little bit there. But Ken, I'll let you go ahead and run with the rest of it.
Yeah, it's an interesting question. If I think about the critical capabilities, I think about, you know, utility networks have a lot of cybersecurity controls already built into them. So if I was to, you know, focus in on, you know, one particular thing, I would recommend some extra attention be around what's called continuous monitoring. And that was a concept that Efrat was talking about. Just in terms of visibility, having that visibility into your network, not only on your endpoints, but all of the network infrastructure at the same time also. So looking at things like, you know, making sure my logs are moving up, they're being processed in the right place, they're getting up to the security information event management system in a proper way. I would look at like the endpoint detection and response agents being part of that visibility grid there. And there's another area that's interesting. It's not necessarily related at all to the private LTE network, but there's a technology called network detection and response that looks at the IP packet flows that are moving across the network. And given the environment that we're in, most utilities are already using a vendor in that space. And I would recommend extending that vendor's visibility into the OAM or the management plane of the actual private LTE network that looks at all of those interfaces there, because that technology is really good at telling you, if you've got anomalous network traffic that's going on, and it can also give you a playback machine. So if someone did get in the network, you can see exactly, what that attacker did, which connections they made, and which actual hosts that they touched. So I would recommend extending that existing system into the management plane of the private LTE network.
Excellent. Thank you. Here's another question. You can talk about how would you secure lateral movement between devices that could be infected inside a private cellular network?
I can respond to that. It's very much related to segmentation approach. So when we're talking about segmentation, we first of all need to decide on our segmentation approach. Is it going to be based on the device type? Is it based on geolocation? It's basically pair your decision as a utility. What is your segmentation approach? After you decide about your segmentation approach, you need a way to actually apply that. So you first of all need to have the visibility and the context of whatever it is that you decided to build your segmentation approach on. And then you need an enforcer as well. In OneLayer specifically, we integrate with firewalls usually in order to provide that. We enrich firewalls so they will have the context so you as a customer can set policies on top of this context. And then the firewall is the one that is actually enforcing the lateral movement, preventing the lateral movement, because you have communication rules between those groups you decided to build your segmentation approach on.
Yeah, I can add a little bit more color to that too. Whenever these networks go in, one of the base security design kind of rules is to keep the management traffic separated from the actual production traffic, be that signaling or the user traffic. So this segmentation strategy that Efrat's talking about is built into the initial design. And the rule is never the two shall meet. So you'll have that basic segmentation there within the original design of the network. And then the placement of those next-gen firewall rules are quite important, and they're really important to think about. So that's one of the reasons why we usually recommend that you have one right between the core and then the data center application, so you can keep that completely separate. Generally, customers have one firewalling all of their network management and security tools also. So there'll be a firewall, a next-gen firewall there at the same time. If you're doing roaming, you'd want another one there for any roaming devices. So you'll want to think through that in terms of, where those next-gen firewalls are and where they're located.
Excellent. Thank you. Another question's come in. Some large school district and library networks don't have a lot of budget challenges. Sorry, have a lot of budget challenges. How might they enhance their cybersecurity in a cost-effective manner as attacks on schools and libraries increase? So this is a little bit adjacent to utilities, but certainly still really important. What we might think of as a campus-like scenario. Thoughts?
I can speak a little bit on it. A general approach, and I mentioned this a little bit earlier, threat actors like easy targets. They like soft targets, right? So however you can harden, your networks, your devices, whatever security tools that you can leverage in a layered approach, will be beneficial to thwart bad actors. You don't necessarily have to have the biggest and most expensive security tools. While some of these best of breed products are fantastic at what they do, a proper architecture and a secure by design approach can help you mitigate some of the risk that your network may have inherently, especially with some of these smarter IoT systems. So I think using a secure by design approach in a layered approach, and really just focusing on simple things like patching, and really just general hygiene within your environment will go a long way.
Excellent. Thank you, Jeremy. Next question. How does your APN structure affect your cyber posture? Thoughts on the APN structure affecting cyber posture?
Yeah, that's pretty important. An APN is basically a subnet. For those that are wondering kind of what that term even means to begin with. And when a cellular device connects into the network, it's assigned a subnet that it's attached to. So in that way, you can use APNs to segment, devices one from another. And that would be an important thing to really think through when you're designing the network initially, because you'll want to group your devices, kind of by device types. So, the meters will get their own maybe APNs that are assigned to them. Your reclosers would get different ones. Other types of devices would have different APNs. And that becomes, a mechanism that you can use in order to segment the network and segment the devices from being able to talk to each other also. A modern cellular core also has a lot of software features built into it, so that even within like an IP subnet, it has the ability to not allow one device to talk to another, even when they're in the same IP subnet. And the normal rules of networking would allow that, but a modern core has some additional, what are called micro-segmentation functionalities that are part of that APN feature set that the question is asking.
Thank you, Ken.
A little bit. So it's true that APNs can be leveraged in order to create segmentation, exactly as Ken explained. We did find this approach pretty much limiting for many of our customers that are asking for a bit more granular options for segmentation. And additionally, you also need to take into account that some devices will have more than one APN if you have more than one application that you want to use. For example, if you are using both voice application and data applications, then maybe your device is going to have two different APNs. And then it starts to be a little bit more complex to base your segmentation approach only on APNs. I'm not saying it's not possible, it definitely is, but the approach here is a bit more complex, and most of the customers we are aware of prefer not to use APNs as their approach for segmentation.
Excellent. Thank you. Next question. How might standards-based private networks enable secure data flows to mitigate risk and enhance grid resilience? That's open to all. Standard-based private networks.
Yeah, I can, there's a couple of standards that are important here. And I'll name two in particular that the utility folks will want to get familiar with. So, and these are 3GPP standards, by the way. So you have what's called TS 33.401. 3GPP loves its numbering schemes, to all these documents and whatnot. That details all of the cybersecurity features that you'll find from a standards basis within the private LTE network. So those will give you a, a listing. It's a big doc, but you'll want to become familiar with that. The other one is TS 33.310, which is a document on network domain security. So it's detailing all of the recommended features and functionality that should be there on the IP network in order to secure this. There's other standards, related to endpoints, but from the network infrastructure side that I live in, those would be the two that I would recommend.
Okay. Thank you, Ken. I think we have time for another one. Why is secure manufacturing and digital identity management, including key management schemes and GSMA compliant eSIM solutions, critical for protecting long lifespan IoT deployments in utility environments? Long question.
Yeah, on this I can take the question, Jean. Well, GSMA compliant and a SIM solution, embedded solution, is, as I mentioned, I started to mention before, could provide several benefits depending on the specific use case. So first of all, could provide tamper-resistant hardware integration inside the module that act as a foundational layer for the upcoming secure communication during the life cycle of the product, and act like as a hardware-based root of trust, where everything can be inside the eSIM can be provisioned securely inside the final product. I mean, device credentials, but more importantly, the remote SIM provisioning capabilities. So having this solution in place can help to support, I would say, scalable remote credential management. So you can have this capability that is essential for large scale IoT deployment without physical intervention, or reducing also operational cost. And I think it also provides greater flexibility in case you need to increase the resilience of the IoT application, in case you need to provide more different SIM profiles and inside the solution, in order to have an increased resilience, connectivity resilience. And also, I would say, can help in reducing logistical cost and challenges associated with the SIM card. And last but not least, as mentioned also by the other experts, reduce several risks inside with physical threat actor scenarios, with physical access to the device, having an embedded SIM with a chipset physically soldered inside the final product. So I think those are the main elements to answer to the question.
Excellent, Enrico. Thank you. We are just about at the top of the hour, so I want to see if there's any final comments from the panelists today. Okay. Well, I appreciate the panelists being on today, taking a lot of time, not only to prepare, but to be on with us today. And as I said on the onslaught, you can meet with all of these great UBBA members at the UBBA Summit and Plugfest in November. Obviously, we'll we'll follow up with the questions we didn't get to today. I want to thank you guys all for being on with us, and look forward to seeing you on the next UVBA webinar. Thanks, everybody. Have a great rest of your day.
Yep.
Thanks so much, Bobby.
Thank you.
Thank you.
Thanks, Bobby.